test. As we see in the Excel here, if you go for data analysis, you have three types of t-test, where to sample for means. It means you have the same group but two different data. So this is completely different, right? We get confused between, if we have two samples, do we know the population of the two samples are equal variance or unequal variance? This is a question. So we can judge this one using what? Using f-tests, right? So this is the right way to choose the right test, right t-test before you start doing this. Okay, so as far as we know, if we have one sample, we can compare one mean for one population sample, right? But if we have two samples from two different populations, we can use f-test to judge the two populations have the same variance or have different variance. If they have equal variance, we can go for t-test for equal variance with this formula for the t-stat, right? Where sp square, okay, this is, they call it the pooled variance, right? The pooled variance having this formula coming from the variance of sample 1 and the variance of sample 2 and the sample 1 size and the sample 2 size, right? Okay, so we have to test using f to check if we have equal variance. As a result of f-test, we go for to compare the two means using t-test with equal variance. Okay, this is a notation. X1 bar is a sample 1 mean, first sample mean. S2, X2 bar is a sample mean for the second sample. And as we said, N1 is the sample size of first sample size, N2 is the second sample size. SP squared, they call it pool variance. What is a pooled variance? It has this formula coming from the sample sizes and the two different variances of the two samples, right? If the result for F test having a summary as they are not equal variance for the two population, whereas the t-test in this case is different from this one. Okay, the difference is S1 squared is different from S2 squared, so no need to find the SP squared, the pooled variance. The pooled variance when we have equal variance only, right? Fine. So the bird-dependent two-sample test is completely different because we have only one group and we get the mean of the difference between the two data for the same group, right? And the standard deviation of the difference also, where the square root for the sample size, because they have the same group, so it is only one sample size. Okay, so if we go for these questions, he's telling you here, okay, look at the end of this one, he said assume the population standard deviation are not the same. Okay, also in the question number 1, assume the two population standard deviation are not the same. Okay, so he's telling you the answer for f-test. Fine, so no need to do the f-test. Catch it? What about this question? This question, how to use t-test to compare the mean. He didn't tell you the standard deviation for the two population are equal or not. So he's asking you, yes, he's telling you one that on the assumption that the population from which samples are drawn have equal variances. Okay, so you can use the t-test for equal variances. But in this question, he didn't give you this assumption here, right? Fine. So to compare the mean for the two population, you have two samples, right? Okay. And you have to do f-test first, unless like this question, he's telling you assume the two population standard deviations are not the same. Okay. And in this one, he's telling you the population standard deviation are not the same. So we are going to use the t-test with unequal variance. Sorry, he said the same. Sorry, he said here the two population standard deviation are not the same, right? And are not the same, it means we are going to use t-test for unequal variance. This one, right? Okay. Now we know in this two exercise, we know the information about the standard deviation of the two population. So we know the right t-test. The right t-test is the two sample t-test for unequal variance. Because of what? Because he's telling me the two population standard deviation are not the same. In this question and also in this question. Also in this question, he's telling me have equal variance. So this one, I'm going to use the t-test for equal variance. What is that? Yes, this is the one for equal variance, right? So before you compare the means, you have to make sure, are you given the information about the two population standard deviation or not? If not, like this question, you have to check using f-test. Okay, if you conclude that they're having equal variance, you go for t-test equal variance. If you are concluding they are having different variance, you go for t-test for unequal variance, right? Let's do it by Excel, okay? I'm sure to solve this question, I'll go for what? Equal variance, right? Let's do it. Can you do it with me, please? If I have a mistake, you can correct me, right? So I have in the first column, this Columbia model. So this is Columbia model. Okay. This is what? Killen model. I input the data here for which is what? Can you give me the value? 5, 4.5, 3.4, 6, 3.3, 4.5, 4.6, 3.5, 5.2, 4.8, 4.4, 4.6, 3.6, and 5. I finish the data for Columbia model, right? Okay. I have to save it from time to time, just in case, right? So I keep it in my desktop. Okay. And I give it to the date f-test and t-test using Excel. Okay, and give it date. Now I'll go back to my data. This data is 3.1, 3.7, 3.6, 4, 3.8, 5.9, 4.9, 3.6, 3.6, 2.3, and 4. Now, I know he's telling me assume what? Two population standard deviation are not the same. So which test I'm going to use to compare the means? Once I know the information, they have unequal variance, right? So can you let me know? Yes, I'll go for data analysis. Okay, what is the alpha here? Alpha, did he give me alpha? Guys, 5%, right? It is 5%. So I'll go for t-test, unequal variance. And I input the first sample. I input the second sample. Sorry, up to here. Okay, now the hypothesis difference is 0 because the null hypothesis is saying they are mu1 equal to mu2, or the mean of Columbia model equal to the mean of KLN1. I have a label. Yes, I have a label. This is the label. Okay, it is 5%. Yes, it is given 5%. I need that to have the result inside this one, so I can put the mouse anywhere here, but I make sure the mouse is in this white box and press OK. I get the result. I can just make it wider. As Briansh have done yesterday, I can shading what I need to say. Yes, I can go for, this is the t-stat. Okay, and this is the t-critical for one tail or two tail. I have to go for, yes, the question is, did he give you anything? Yes, the word here is the keyword, larger. Larger, it means sorry, I'm looking for this one, sorry. We have 5%, but do we have any key here saying equal or unequal, greater than? Yes, the Columbia model earn more. More, it's mean greater than. So I have to write the null hypothesis here. What is the null hypothesis? The null hypothesis say the mean of Columbia model for the null hypothesis, right, equal to the mean of KLN model. This is what? This is the null hypothesis. I can copy this one and paste it here and change the null by the alternative HA, and instead of equal I have larger than, so I have this greater than. From this one I conclude that it is right tail or left tail? Right tail, right? Okay, this is very important for you. Why it is very important? Because when I go for the critical value, I will go for critical value for one tail, right? Okay, so the t-stat is less than the t-critical. So this is the t-stat value. This is coming from the formula, right? Is it less than, okay, the critical value, right? The critical value Okay, because it is less than, I can make it red and make it bigger just to be very clear. So are you going to reject or accept the null hypothesis? Yeah, T stat before the T critical. If it passed the T critical, it will be in the rejection area. So what? We accept the null hypothesis. What is the null hypothesis? It is in front of your eyes here, H naught. So what? So the mean of this one is equal to this one, right? So I can paste it here, right? Can you write the conclusion? Yes, I can write the conclusion. So the summary is there is no significant difference. Yes, there is no significance in the averages. Averages mean the means, averages of both Columbia and Kellen model. Okay. So once you accept the null hypothesis, you reject the alternative one. So you can write the summary as like this, or the mean of Columbia model is not greater than the mean of the Kellen model. It's up to you, right? Also, you can take the decision using the p-value, right? So you can say go this way, or this will be, yes, you have 5%. This is bigger than 0.05, which is equal to the level of significance, right? Okay, alpha. So you will have the same decision, right? So using the p-value to take the decision, or comparing the t-stat with the t-value with the t-critical, it's up to you, right? You do the yellow or the orange one. Okay, easy? Yes. So this is, I call it t-test with, I use equal variance or unequal variance, unequal variance here, up to the question, right? Because in the question he say, assume the two population standard deviation are not the same. This is why I go for unequal variance t-test. Okay, so t-test with unequal variance, So it is not up to you. It is up to the information you have, right? So I have done this one. Okay,